Hey folks, welcome back for another episode of Code Club. In this episode, we are going to be building this figure that I obtained from the US Census Bureau. This was posted actually last January in 2024 as part of National Poverty Awareness Month here in the United States. And so because it's January again, as this tends to happen every year, this is again National Poverty Awareness Month. And so I thought this was a pretty intriguing figure. Looking at the number of people in poverty as well as the rate of people in poverty going back to 1959 up through 2022. I guess if I wanted to, I could go about trying to get 23 and 24 data. Actually, I don't know if the 24 data is available yet. But anyway, a couple of things stood out to me about this figure that I thought was pretty interesting. First of all, it is a faceted plot. We've been talking about facets and ways to facet plots in the last couple of episodes. Within those facets, though, it is a line plot, right? And so there's a purple line for the number of people in poverty, a green line for the poverty rate. Some of you might be thinking, well, why didn't they just make this one plot and have a double y-axis? Because double y-axes are horrible. So I do have an episode on how to make a double y-axis from a while back. But like I said, that is a pretty poor data visualization practice. Something else that's going on within each of the facets is that there are rectangles, right? And these rectangles indicate when there was a recession, as indicated here in the upper right corner. And so that's interesting, right? They're overlaying the poverty data on top of the recession. A recession is when you typically think of there being economic downturn, right? And so then the question is, do we see rises in poverty when there's economic downturn? And I think if you kind of look at these, you see the number of poverty going up, but it never comes down during a recession, right? So that's interesting. They've also labeled the lines as well as putting the units in the upper left corner. And so a critique I would have would be, I would perhaps rather have poverty rate up here next to percent and perhaps in parentheses put the unit like a percent sign. And the same thing for number in poverty. So number in poverty, parentheses in millions, right? Something like that. Another critique is this broken y-axis. We've talked about broken y-axes or x-axes in previous episodes. Again, it's generally considered a bad practice, but then there's this trade-off, right? If you had 0 with no broken axis, then the range would go from about 23% up to about 47% or so, right? And so you might not see all the nuances and change in the data. But it's really only a hard and fast rule that you have to include 0 if you're using a bar plot. And so if you're looking at a line plot and looking at the changes in poverty, say, then you don't really need that because the absolute values on the y-axis aren't so critical. Something I find interesting about the line plot in here is that if you look closely, there's actually 3 different lines in each of these facets, right? So there's this purple line, and then there's a lighter purple line here, and then there's a purple line again. If you read down in the footnotes, you'll see that a different method was used for this range of time. So I think this is an interesting way of showing that the data are all of the same type, right? That they're all number of poverty, but by using a different shade of purple or a different shade of green, we can say there's something interesting about this. Go look down below in the footnote. While I'm over here on the right side of the plot, one other thing that stood out to me about this plot is that they have the final number for 2022 over here in the right-hand margin. And I thought that was a pretty slick way of kind of pulling the whole figure together. Finally, something I noticed is that this font, I'm pretty sure is Franklin, which we have been using in making some of those New York Times visualizations. And so we'll perhaps see about how we can bring in the Franklin font again for this visualization. So now we need to think about where do we get the data? We could of course simulate it, but that's never nearly as much fun as going out into the wild and getting the real data. If we go to the US Census Bureau website, I'll put a link to this page down below. In here, you'll see this figure 1 from a report that they had made. And if you go further down, you'll see a link for poverty data tables. So we click on that. And if we come down further, we'll see historical poverty tables, people and families, 1959 to 2023. Hey, that's what we're doing. So we'll go ahead and click on that. And the table that we want is poverty status of people by family relationship, race, and Hispanic origin. So we'll go ahead and click this. It'll download as an Excel file. So I'll put all these links down below in the description for this episode so that you can go get it. I'll also have many of these links in the R script that we're building. The other bit of information that we need for this plot are the timings of the recessions. So in a previous newsletter, which again, you can find down below linked, and you should definitely be subscribing because I present these plots that I'm presenting to you here on YouTube a week or so earlier in this newsletter to give you time to think about how you would build it. And so in that newsletter article, I said I would probably go into Wikipedia and scrape out the dates for different recessions. And so Rob Hansen read that. So he sent me to the National Bureau of Economic Research and even linked right off on this homepage of nbr.org is a link for business cycle dating information. So we see on this page actually an interactive plot showing the unemployment rate with recessions going back to 1948. Actually, it says 1948, but it only goes back to 1978. And so maybe the downloaded PDF goes back further. Regardless, what we're interested in is this business cycle dates. And this then shows us a table with all of the past recessions going back to 1857, right? And then coming forward to February of 2020, right? And so again, we're kind of trading Wikipedia for this, except we could either get it as an Excel file or what Rob recommended was a JSON file formatted file. And so that's going to be under business cycle dates. And so we could actually interact with this page, with this file, this JSON file, to get the beginning and end of the recession data, and that has all the dates. And so the peak is the beginning of the recession, the trough is the end of the recession. Heading over to RStudio, I have this poverty.r script already created. It's basically a template with some of the libraries I know we'll use, getting access to that JSON file that Rob sent me this code, which is very appreciated. And then I have a stub in here for reading the Excel file using readexcel from the readexcel package. I think that's right, but we'll see. So let's go ahead and load all this. And if we do cycles, we then see cycles has, what do we see? So we've got the peak and the trough, the beginning date and the end date. And so in Rob's code he gave us, he used a mutate across all of the columns to apply the YMD, year, month, date function to those columns to get them to be in a nice standardized format. Maybe in here, I'll go ahead and say select, and I'll do beginning equals peak and equals trough. And so now if we look at cycles, oh, this is actually coming out as a data frame rather than as a tibble, which is why it's showing all the data, but we then see that's labeled. So to get the data from 1959 forward, let's go ahead and apply a filter, and I will then do year on beginning. And if we had year on beginning, so let's do year on 2024, 01, 04, that will give us nothing. Oh, this needs to be a date or probably a string. And that gives us the year, right? Okay, so this should then give us the year, and we want those to be greater than or equal to 1959. And so now if we look at cycles, we see that there were 9 recessions starting in 1960 going through 2020. And so this will be really good for making those rectangles. All right, so I think that's good for our cycles. The next thing, of course, is this spreadsheet. So this is that table 2 opened in Excel. So we can download it and use it, or we can use the URL. I think I'll try to use the URL. And so we see that we actually have 2023 data. So we do get that last available year of data. So looking through this, we see there's a year, there's all people, and then there's families with and without a spouse present or unrelated individuals. I'm really only interested in columns B, C, and D here as well. Oh, A, B, C, and D, right? And if we scroll down, what we see is that they've actually concatenated together a number of data tables, right, for different races. I'm really interested in all races. And so we're really going to want to focus on, say, like A9 down to A75 over to D75. And so we can do that with readexcel. And so I don't work with Excel files a lot. So let's go ahead and look at readexcel. So this is the help for the package. And so I think what I want is readexcel. And so this then gives us the path, the sheet, and the range. And so the range, I believe I can give kind of the letter number combination like we see here to get the range we want. And so in read Excel, we'll go ahead and do range equals, and I think I said A2 to D what? So D75, right? And so I'm leaving off the headers here because this is kind of weird, right? Actually, let's see what happens if we include that. And actually I said A2, but actually we're going down to A9. But let's go ahead and do A8 and see what that gets us. So A8 to D75. So I forgot to put in Excel with the underscore. So it's not happy with me giving it a URL. And so I'm going to go ahead and take this and plop it up here. And I'll make a comment to say, saved this to desktop. I'll go ahead and put that in for the path. And now I need to move this file into my desktop. So I'll go ahead and copy that over. And so now let's try this. Now it works. And let's see what poverty data looks like. And so like I said, we get kind of this funky heading, right? And so I think what I'd rather do is skip the funky heading. And let's start at row 9. And then we can put in our own column names. So let's go and do 9. And then we'll do call names equals. And then we'll do year, total, number, and percent. And so now when I look at poverty data, I get the year, the total, the number, and the percent. I'm noticing I also have this 2 and 3, and that's reminding me that there were a few years of data, again, where they're using that different model. And so you'll notice for 2017, there are 2 values, right? 2 rows in the data. And so let's go ahead and look at poverty data over, let's go to 20 lines. So I'll pipe this to print n equals 20. And so we see, again, a number of these footnotes in here, but we see 2017 has 2, as well as 2013. And again, if you went back and looked at the footnotes, you'd see that between 2013 and 2017, they changed their methodology. So I'm first going to go ahead and remove those footnotes. And so I'll do a mutate on year, and we'll do str replace on year. And then the pattern we're going to look for is a space and a parenthesis number parenthesis. And so because a parenthesis is meaningful, we need to use 2 backslashes, and then I'll put in a dot star to match any number of characters, and then a close parenthesis. And so we'll match that, and then we'll, actually I don't need that parenthesis there, and then we're going to replace it with nothing. And so I think we need one more parenthesis here. And so let's go ahead and run all this. And so now we see that that footnote went away. So now I want to make a column that I'm going to call method that will be A for the first span of dates, B for the second span of dates, and then C for the more recent span of dates to denote the 3 different methods that were used. And so I'm going to go ahead and do last value and pipe that to print n equals 20. And so we see that basically from rows 57 to 13 is going to be one method, and then between 8 and 12 will be another method, and then 1 to 7 will be another method. I'm going to do this with a case when, and so we'll then do method equals case when, and then in here I'll do row number, and so row number will tell us the row number in the tibble, and we'll say when the row number is greater than or equal to 8, right? So that would be this, and when row number is less than or equal to what? 12, I believe, right? So that will get us these 5 rows as being the same type. And so then we'll make that 12. And so I'm doing this first because, why am I doing this first? Because this will be the first question that case when asks, right? And so I'm going to assign that to B. And so if this is true, it'll assign B, and then it kicks out of case when. But if the row number is, say, 7, it's going to go to the next value. And so I could do like row number less than 8, row number greater than 12. But that's not super portable because, if we come next year and we get 2024 data, then this won't really work. We're going to have to do some fine tuning. And even this, right, this will be wrong next year because we'll basically have to increment all the row numbers by 1. So I don't really want to do too much of that. So let's go ahead then and do year greater than 2017. we'll assign that to be C. And then year less than 2013, we'll assign that to be A. So you might be thinking like, well, but this is a 2013. But again, this is row 12. And because row 12 will satisfy this as true, the value of method will be B, and we'll never see any of these other rows. So if we run that, and then we look at poverty data, again, let's look at the first 20 rows. We now see what? Oh, we've got some NAs. Oh, right. Because we have NAs for 2017. And so what I wanted this to be was year greater than or equal to 2017 and year less than or equal to 2013. And so then we can look at this, and we now see that this second 2013 value is method A, and the first 2017 method is C. So great. Now we have all of our data. It's a little bit convoluted, but hey, now we have the data that we can plot, right? And so let's go ahead and take poverty data, and we'll get going with our plot. So we'll do ggplot AES. On the x-axis, we'll put the year. On the y-axis, now what are we going to put on the y-axis? Because we're going to facet this, we actually want to gather these two columns together. We want to pivot them longer. So we're not totally done with our poverty data just yet. So let's go ahead and I'll do a select to remove the total column, and then we'll go ahead and pivot longer. And the calls that we'll use will be number and percent. And so if we now look at poverty data, we see that for each year, we have two rows, right? So we have the number and the percent, as well as the value. That all, I think, looks pretty good. And so now on the Y, we can put the value, and then the color is going to be driven by the method and the name. So I'm not done up here just yet. We'll go ahead and do a mutate with method name, and I'll then do paste method name. And so now if we look at poverty data, we see that we now have C space number. Maybe I'll go ahead and change that with a sep to be an underscore. And again, if we look at poverty data, we now see that we have C underscore number, right? And so this is method name, and that's going to be the color is the method name. And then we'll go ahead and add to that geom underscore line. And it says each group consists of only one observation. Do you need the group aesthetic? Yes, yes, I do. So we'll go ahead and do group equals method name. Very good. This is our plot. And so we see the three different colors in our plot for the number. And of course, the percent is down towards 0. And so this is one of the reasons we're going to want to facet this. So let's go ahead and do that. So in here, we'll do facet wrap, and we'll do nrow equals 1. And we need to tell it what to facet by. And so we're going to facet by the name. And I need a tilde before that name. And so now I've got two plots, the number and the percent. And I think I did nrow equals 1. I wanted nrow equals 2. Okay, there we go. Now we have the number and the percent. I would like to free up the y-axis. And so in here, we'll do scale equals free underscore y. Now we have our number on the top and percent on the bottom. It works out that that's the same order that they had in their figure. And so that looks good. So let's go ahead and fix the color, because once we fix the colors, then I feel like we can get rid of that legend. So we can do that up here in scale color manual, and we'll have breaks. And so the breaks then are in poverty data, right? And I always do count on this, and people always say you should use distinct. So I'll use distinct. Distinct on method name. And so here are our method names. So I'll go ahead and bring that up here. And I don't need the number preceding it. All right, clean this up a bit. All right, so this is my vector of names. I've sorted it by whether it's a number or a percent. And so we'll go ahead and put this on a line. And of course, this goes off the right side of the screen, so I'll break this here. And so those are the breaks. And then we want the values. And so the values on the top for the number, that's that purple color, right? So we'll do purple, and then the other is going to be purple. And then what does violet look like? it's like a lighter color, right? So these aren't going to be the exact colors that they're using. Is there a dark purple? No. So I'm going to use these. I know they're not a perfect match, but I think they're going to be close enough for illustrative purposes. And then the bottom, we have green, right? And so let's use forest green, lime green, sure, and then forest green. Okay. Again, these aren't perfect matches, but it'll get the job done. And so then we can go ahead and close off that scale color manual. And so now we see that we've got that two-tone appearance with the line break for the different colors. I'll go ahead and remove that legend then by doing show.legend equals false. And so now we have all that great real estate. Of course, we're going to put a margin in on the right side of the plot, but we'll deal with that in a bit. So the part of the plot that we haven't included yet is when the recessions occurred. And so we're going to go ahead and include that as well. And so we have to think about how to do this, I think. We are going to use cycles as our data, and we're going to use a geom, and I think it's like geom rect, and our data is going to be the cycles, right? And so then we need to think about the aesthetic. So the mapping equals, and let's go ahead and put these on separate lines. We'll do AES. I'm not totally sure of the aesthetics for geom rect, so let's look at that real quick. So geom rect, it says, has xmin, xmax, ymin, ymax. Let's give that a shot. So our xmin and xmax are going to come to us with beginning and end, right? And so we'll do xmin equals beginning, xmax will be end, and then we need ymin, I'm going to make it 0, and ymax, let's make that 50,000. This is not going to be right, but we'll deal with that later. And we'll do inherit.aes equals false, because the aesthetics that we're using for those rectangles are going to be different than what we have up here, right? Like we're not using group. We don't have a method name. That doesn't make sense. One thing I'm thinking about, though, is that we don't have a name column. Let's see what happens when we run this. And so it can't convert xdate to double. Right. So our cycles needs some help, right? That we've got beginning and end are dates, not years, whereas what we currently have are years on the x-axis. So I think what I'd like to do is convert this to like a Julian date and then get the fraction of that of 365, if that makes sense. All right, so I'm going to be doing some work back up here with cycles. And again, we get the beginning and the end, and we'll do a mutate, and let's do, I'll call it A for now. So we'll do Y day on beginning. And so that gives us, so like April 1st is the 92nd day of the year. So then we're going to divide it by the number of days in the year. I'll do 365 because I don't want to bother with trying to figure out if it's 366 or 365 because no one's going to be able to tell, right? And so then that will get us the fraction, but then we want to add it to the year. So we'll do year on beginning to get the year and then add that fractional component, right? And so now we have 1960.252, and that will be the beginning. So I'm going to reassign this to be beginning, and then we'll do the same thing for the end. And this is not exactly dry, but hey, you know, I'm only repeating it once, so no big deal. If you want to make a function, I would encourage you to do that. And maybe there actually is a function already. So that gets us a beginning and an end that is a quantifiable value. The other thing that we need to add then is a name column for doing the faceting. So I'm going to do number equals X, percent equals Y. And again, this is just creating dummy variables that then I can go ahead and do pivot longer on number and percent. And this needed to be in calls. I think I heard one of you say that. Well, actually, it needs to be calls equals a vector of these values, right? So we'll do equals C on that. And I need a closing parenthesis here. So now we have the beginning and the end as double, and then number and percent, and we have a value column. And so something I'm thinking is that we want to set the minimum and maximum value for our rectangles, right? So there's on the top goes from like 0 to 50 and the bottom 0 to 25. I'm not sold that I want this to have the broken axis. And so I think what I'll do is I will create another tibble. So let's go ahead and save this as cycles, but I'm going to create another tibble that I'll call cycles limits. We'll do tibble and we'll do name, and that's going to be number and percent, and then I'll do y min. So the min on number was 0, and on percent was also 0, right? And then y max, and then the y max was 50 and 25. And so let's go ahead and load cycle limits. And I think what I'll then do is take cycles, and then I'm going to join cycle limits into cycles on that name column, right? And so let's see, if we'll do inner join, what's coming through the pipeline with cycle limits by equals name. And it's not happy. Cycle limits, not cycles limits. Okay, now let's try cycles. Great, so now we have the beginning, the end, the y min, the y max, right? This is basically x min, x max, y min, y max. And if we want to change the minimum values or the maximum values, we can change it in this table. Good. So now let's come back to our plot where we had geomrect and we had y min. And so here I'll do y min because I had that column name in cycles, and we'll then do y max. And I need a plus sign here. And so what I'm seeing is something really weird, is that I appear to have my rectangles over here on the right, and on the left, I have my line plots. And something that I recall is that when we were making the poverty data, we did this string replace. And so if I bet if we look at poverty data, this year column, it's a character, right? Whereas our cycles, the first column, or the beginning and end, are doubles. And so we need to make this output a double. And so we'll pipe this to as.numeric. Now if we look at poverty data, we see that that first column is a double. And now let's plot it. And so now we have our very nice bars going all the way across. But I can barely see down here that I have my rectangles. And that's because my scaling is off, right? So their scaling went up to 50, whereas mine goes up to 50,000. And so we're off by 1,000. That's no big deal. Again, we can come back up here and do 50,000. Rerunning everything, we now get those rectangles. Of course, my rectangles are on top of the line. Let's go ahead and flip the order, move geom line to after geom rect. Great. Let's get that color to be like baby blue maybe, or I think it's light blue. So we'll do fill equals light blue, get the comma. Now what I'm worried about is the padding around the plot, right? And so theirs has no padding on the y-axis, but there does appear to be padding on the x-axis. So we could do that with, let's down here with our scale. I'll go ahead and put this after scale color manual. I'll do scale y continuous, and we'll do expand equals c 0, 0. That should get rid of that vertical expansion. And so now we see that, sure enough, those rectangles go from top to bottom without any extra space there. Let's go ahead and modify the y-axis of our number, right? So it's going by 10,000s. And so I would like to change that. And so I'm tempted to take the value and divide it by 1,000, but that would also divide those percents by 1,000. That's not what I want to do. So let's go ahead in number and let's divide number by 1,000 back up here where we're defining poverty data, right? In here, let me see what we're calling it, right? So that was per number, right? And so here, let's go ahead, we'll do number equals number divided by 1,000. And then also, of course, we're going to need to drop this down to 50 because it had been 50,000 and now it's 50. So now we are going 0, 10, 20, 30, 40, 50, and 0 to 25. I would, I think, prefer to have this go from 20 to 50. In their original plot, they went basically to 20, right? They had 20, but they renamed it 0 and put a break in there. I don't want to have the broken axis because, again, I think it's a bad practice. So up here for the min for number, we'll make that 20. And so now we see we have the 20, 30, 40, 50. It is putting in automatic break sizes. I think I want mine to go every 5, kind of like they do. And so back up here and scale y continuous. So we'll do breaks, and we'll do seek from 0 to 50 by 5. And so now we get breaks every 5 million, right? And we have breaks every 5%. So let's go ahead and put on our theme classic, and we can start making the plot look a bit more presentable. Theme classic. All right, that gets us a white background. So let's go ahead and start cleaning up the labels and titles on our plot. We can come up here and I will do labs, x equals null, y equals null, and then title from the original. I'll do number in poverty and poverty rate, and I'll plop that in there. And then caption will be this whole monstrosity. So much stuff. And I'm going to end up using ggtext to format this with element text box simple. So I'll go ahead and put in the BRs for the line breaks after each line. And then we need a plus at the end here. And then I think what we can also use is a tag. And the tag will be like this figure 1, right? So we'll go ahead and plop that in. Great. So it's there. We'll wait on doing the theming, so hold on. But now let's go ahead and worry about the titles of the 2 facets. And I'll come back up here and I'll do facet labels. And this is going to be a named vector. And so we have number, and we'll also have %. And this is what I'm going to want to call these 2 things. So you'll recall in this, they had number in poverty and number in millions. So I'm going to take this number in poverty, and I'm going to do it a bit differently. So I'll do number in poverty, and I'll do millions, poverty rate, and I'll do %sign. Okay, so then we have facet labels, and then we can come back down to where we do our faceting. So we come down here to where we do faceting, and we'll do labeler, and we'll do labeler, name, facet labels. And so now we have those titles. So let's now look at our x-axis. So we go from 1960 to 2020. The original goes from 1959 to 2022. I think we actually go up to 2023, right? So if I look at poverty, data, tail, or head probably is what I want, the beginning, 2023. So let's go ahead and add scale x continuous, and we'll do limits, and we'll do 1959, comma 2023, get a plus sign at the end of that. So again, that's what we had. One thing I'm noticing, again, is that we do have that expansion to the left and right. I think I'm going to turn it off because in theirs, they go back like half a year. So maybe I could make my limits 1958.5 to 2023.5, and I could then turn off the expand to not have such a fat padding on either side. And that really brings it in, but of course we don't see the labels on the x-axis. Theirs goes 1959 and then picks up going by 5s to 2022. I don't really like that. I will do by 5s, but I'm not a big fan of having those uneven increments like they have here. Maybe it does show that the beginning is 2022 and 1959, but up here they have 1959 to 2022. And so actually I need to fix mine to be 20 to 23, yeah, so this should be 24, and then this should be 23. All right. And let's see, in here in scale X continuous, let's go ahead and do breaks, and we'll just seek 1960 to 2020 by 5s. And so then that gets us our annual breaks across the x-axis. So one thing that their plot has are these minor tick marks. They basically tick every year. This is something that is newly available within ggplot2 in the last year or so. And down here after the scale X continuous, I'll go ahead and do guides. I'll do X equals guide axis. And I can then say minor ticks equals true. I talked about this in an episode a while back, but it's always good to remind us of these things. So I'll go ahead and include that. But I also then need to add the minor breaks on the x-axis. So I'll do minor breaks equals seek, or I guess I can just do 1959 to 2023. And then that gets us our tick marks. Those minor tick marks, I think, are a little bit smaller than the major tick marks. I would like them to be a bit longer. Theirs, of course, go up into the plot. So let's see if we can't do that as well. And so we'll do that with theme. And in theme, we can do axis.minor.ticks.x.bottom. So you have to specify the whole thing. And we'll do element line. And I guess I don't need that so much as the length, right? We'll leave that there just because we'll probably end up changing the thickness of things. We'll do axis.minor.ticks.x, length.x.bottom. And then we can do unit, and let's do 1 pt. And so those that we can see are short. Maybe we want it to be -3, so that'll go into the plot, right? So that now goes up into the plot. And then maybe, let's go ahead and make this actually -2. And then I'll do axis ticks.length.x.bottom. And let's maybe make it 4. So this should be the major ticks. So I think that looks a lot better. One thing we might want to do is go ahead and put the x-axis on the upper plot like they have. We could probably do that back up in facet wrap. We could do axes equals all y, I believe it is. Maybe it's all x. Sometimes I get my coordinates screwed up, so x. So now we've got a problem in that I would like to get rid of the years on the upper panel, but I don't have a way to do that in pure ggplot2. I could then, if I got rid of, I have a way to do it with getting rid of the years, but it will also get rid of those tick marks. That would basically be putting in a geom h line. There's another package out there called ggh4x. This video is very long as it is, and so I don't want to go down that rabbit hole. I think what I'll end up doing is removing the x-axis from the upper panel. I think having these vertical rectangles does the trick that I'm trying to go for anyway. So we'll go ahead and remove that axes argument. And so now let's start cleaning this up a bit. Specifically, this tag is in the margin. There are probably ways to specifically format the tag. I'm not going to go down that rabbit hole just quite right now because it's not something I'm familiar with. So I'm going to do what I'm familiar with. And that's there's a title and a subtitle. So I think I'll make what I'm currently calling the tag the title and the title the subtitle. And so now those are left aligned on the panel. And so we can left align them on the plot. The same for the caption. We'll do plot.title.position equals plot and plot.caption.position equals plot. And so now that is left justified. We can't see it, of course, down here with the caption because it's right justified. So let's go ahead and make that left justified. So we'll do plot.caption. So I'm going to do element text box simple. And we'll do hjust equals 0. And so element text box simple comes to us from ggtext. So we'll do library ggtext. And so it is complaining that I have a hyperlink. And so hyperlinks aren't currently supported. And so let's go ahead and remove that, the braces. And I think that should work. Nope. Where do I have the A? Don't have the A. I think it just doesn't like that I have a hyperlink in the title here, right? What if I remove that? Does the hyperlink go away? No. I'll just say census.gov. That works. And so now we see we've got our caption down here as well as our title. Good. Now we can begin the process of doing our theming. Let's start with getting in our font. So we'll do library show text. So we'll then do font, add Google, and we'll do Libre Franklin. And I'm going to call that Franklin. I then need to do show text auto, and then show text opts, DPI equals 300 to get the right resolution. And so now I can use Franklin as my font family throughout the rest of the plot. And so I'm going to do that in theme, and I'm going to use the text argument, and we'll do element text family equals Franklin. And then this gets us the Franklin font. It's somewhat distinctive from what we previously had, but I think that looks pretty good. So I'm going to go ahead and shrink the size of the title. So remember, the title is that fig1. So we'll do plot.title element text, and we'll do size equals, let's do 18. And then we're going to want to do plot subtitle, and that's going to be bigger. So let's make that 22, and we'll do face equals bold. That's too big. We basically want it to be the width of our plot. And so maybe that's where I should start, is let's kind of work that down. Let's go make that 10, and I think that's pretty good. And so now we want to shrink down fig1. Let's make that 8. And so I think that's a good size. And then for our title, let's make that 7. And I think that looks good. The title is a bluish color in theirs. Let's go ahead and make that Dodger blue, just because I always have Dodger blue at least once in every video. We'll do color equals Dodger blue. And I've got this in the wrong place. I have it in the title, whereas kind of using a hack, right, to get it in the subtitle. Oh, I forgot to remove it from my title. So we'll go ahead and remove that. So it's not exactly the same blue, but whatever, that's fine. So let's go ahead and look at the titles on our two facets. And so what we can first do is remove the strip background so that we don't have that border. And so we'll do strip.background equals element blank to remove that. And then strip.text element text, and we'll do hjust equals 0. And so that brings it over to the left. Theirs is right on the axis, and so we probably have a margin to the left on ours. So let's go ahead and add, so we'll do margin equals margin, and then on the left, let's make that 0. And so that made it 0 all the way around. And so the left is 0, and then the bottom, let's make that 3. I think it looks pretty good. The font should be a bit smaller. So let's do size equals 7, and I think that's pretty nice. We can now modify the font for the axis text. And so I think that's the same 7 size, right? We'll do axis.text equals element text size equals 7. That's pretty nice. The lines are really chunky, and I'm noticing actually the y-axis doesn't have any tick marks, but there are grid lines. And the grid lines go on top of the rectangle, but behind the line. So I'm going to need to do that with the geom h line. So let's go ahead, and while we're at it, we can do axis.ticks.y element blank. And then, like I said, we'll come back up here to our geoms, and we want this to be between the rectangle and the line. So we'll do geom h line, so y-intercept, and we'll do seek 0 to 50 by 5s. I'm a little bit worried that we're going to get 0 to 50 by 5s on both panels. We'll see what happens. Sure enough, that's what happened. So I think I need to try a different approach here. I'm going to make another data frame. So I'll come back up here to the top, and I'll make a data frame that I'll call grid lines. And this will be a tibble. And let's see. So we're going to have name, because that's what we're going to facet on. And then we're going to have the y-intercepts. So we'll have name equaling basically this, right? Number and percent. And then we're going to have intercept. And it's going to be from 20 to 50 by 5s and 0 to 25 by 5. So we'll do seek 20, 50 by 5s, and then seek 0, 25 by 5s, right? And so then this is going to create a vector of these values, right? And so then we need to repeat the number of times, right? So it's 1, 2, 3, 4, 5, 6, 7. Repeat that 7 times. We also want to repeat percent, and that's going to get repeated 6 times. And so now we have grid lines as this tibble, right? And so I think what we can do with this is come back to our geom h line, and we'll then say data equals grid lines, and then AES y-intercept equals intercept. So we'll go ahead and try that. And hey, what do you know? That worked. Awesome. I'm noticing that this bottom line appears to be getting clipped. So let's go ahead and also the top line is getting clipped. We're probably going to make those more thin, but let's go ahead and turn off the clipping. And we can do that up here. I'll go ahead and do chord Cartesian clip equals off. And then let's go ahead and make the lines a bit thinner here in geom_h line. We'll do line width equals 0.25, and that looks pretty good. I think the color is actually gray. We can add that in here as well. Color equals gray. Good, I think that looks nice. So the axes all the way around and tick marks are also a thinner line, and they are black. So let's make them the same line thickness. So let's see, we have all sorts of stuff everywhere. So I'm going to try to clean this up a little bit. Let's get all the axis stuff together. So these are the ticks, the Y. So let's go ahead and do axis.ticks.x element line width equals 0.25. And then we'll also do axis.line equals element line width equals 0.25. Oh, and I misspelled line width. So that looks pretty nice. So I notice on the right, they also have a line that maybe we can add axis line dot y dot right equals element line width equals 0.25. And it was gray, I believe. So that didn't work. I'm going to try something different, which would be panel.border. And we'll do element rect color equals gray, line width equals 0.25, and then fill equals NA. And so this should draw a border around the whole thing. And so now what we see, of course, is that border all the way around, but we're getting our tick marks back on the y-axis. Why is that? So we had axis ticks x. Oh, I must have accidentally removed the axis ticks y element blank. So the axis ticks dot y equals element blank. So that looks a lot better. Now let's think about the bottom. And this font is a little bit smaller than what we had for our axis text. And our axis text, we had 7. So let's go ahead and make our caption maybe like 6. So we have plot caption up here already. We'll do size equals, let's try 6. So it looks pretty good. They do have a margin between the caption and the plot. And so we can do that as well back up here with plot caption. We can do margin equals margin. And then let's do t equals 20. Maybe that's too far. Let's go ahead and up it to 15, and I'll call that good. Looking at theirs, I noticed that their line is a bit thicker than my line. Let's go ahead and quickly increase that here. We can do that with geom_line, and I can then do line width equals 1. So 2 things that they have that I still don't have are this legend for recession, as well as the numbers in the right-hand margin. Let's go ahead and try to do the right-hand margin. For that, we'll go ahead and make yet another data table, another tibble. So many tibbles. So here we'll do text annotation, and that'll be a tibble. And on the x-axis, we're going to want to put the year, basically, where that is going to sit. And so I'm going to say that that's like right at 24 in our case, because we go out to 23. Let's take it out to 24. And so x will be 24, 24. And then for y, we're going to want the values for the number and the percent. And then we're also going to want the name, right? So here we'll put like number and percent. That way, when we add this in with like geom text, the name faceting will work. And so I just want to make sure we get something close. So here I'll put 37 for the number and 11 for the percent. And then we also need a label. So we'll do label C37 and 11. Just want to make sure this works before I go through the rigmarole of getting it perfect. So we'll add text annotation. And this needs to be in quotes, the number and percent. All right. So now we can take text annotation and add it in down here. We'll take geom text with text annotation as the data. And we'll then do mapping equals AES, X equals X, Y equals Y, label equals label. And I need another parenthesis here. And it's complaining I don't have method name. So we need to tell it to not inherit the AES. And so where did we have geom text here? Great. So now we can do inherit.AES equals false. And so it's complaining that it removed 2 rows containing missing values or values outside of the scale range. And I think that is because I defined my limits in scale X continuous. So let's do it down here in chord Cartesian. So scale X continuous will remove data that falls outside of the limits, whereas chord Cartesian leaves it, but doesn't show it. And because we have clip equals off, it actually will show it. So we'll go ahead and grab this limits, and we'll plop it in here, but we need to say xlim. So nothing happened. Let me go back and look at my text annotation. Oh, I put 24 rather than 2024. All right, now let's try that again. All right, and so now I see the number there, but of course it's getting clipped because there's just not enough margin to the right, and also it's centering it. So let's come back up to our geom text, and we'll make a couple changes. And so with this, we'll do hjust equals 0, so it's left justified. Then down to our theme, we'll do plot.margin equals margin, and we'll do 3 all the way around. But on the right, so this one here, let's go ahead and make that 20 so that we have extra spacing there. Now what we need to do is we need to improve what that looks like, right? So this says million and percent for the label. And so let's scroll up here. And for the label, that's going to be 37 million and 11%. All right, so I can kind of see the edge of it there, but we need more margin. And also our font needs to be a bit smaller, probably the same size font as what we have on the axes, which again, I believe is 8. So let's come to our geom text and we'll do size equals 8, size.unit equals pt. And then our margin, we need to be quite a bit wider. So let's make this maybe 40. So we need more space, but I also noticed that we don't have the Franklin font. And so let's add that to our geom text. And here we can then say family equals Franklin. And then again, for our margin, we can go up to 50. Now we need the actual values here in the margin. And so we got that with this text annotation, right? So I'm going to grab text annotation, bring it down below poverty data. And maybe what we can do is to take poverty data, filter year equals 2023. That gets us this, right? Have our year and our value, right? So that's basically we want, but the year, we can add a year. We can add 1 to the year, right? So we'll then do mutate year equals year plus 1 to move it to the right outside of the plotting window. And then we can also do label. So I think I can do paste on value, and I'm going to give it 2 different things to concatenate onto it. I don't know if that will work, but for number, we'll say million. And then for the percent, we'll say percent. And I think I've got too many parentheses here. Hey, that actually worked. What do you know? Cool. So this is going to be my text annotation. So I didn't need all that after all. So we'll get that. And then down in geom text annotation, and then X is going to be the year, Y is going to be the value, and then label is the label. All right, good. But we need more space to the right there. So we'll, of course, up our margin to say 60. So one thing I'm noticing is that the right margin is also obviously getting applied to the caption. Maybe I could turn off that for the caption by doing R equals minus. What happens if we do like minus 30? It goes over. So let's try minus 60. And that way then we can have our caption wrap independently of the rest of the plot, right? So cool. That that looks pretty nice. So by setting the negative right margin, we have this text in the caption going off to the right. And I'm pretty happy with the way that looks. So the final thing that I don't have is the legend for my recession data. So I want to go ahead and put that in. I think what I can do is back up here with geom rect, right? I had fill equals light blue. And so I'm going to go ahead and add to all of these aesthetics. I'll do fill equals, so I'll put fill color, and I'll go ahead and remove this fill. And so now I have a legend for my fill color. That's that hideous color, right? And so now I want to use scale fill manual to clean that up, right? And so now what we can do up here, we could do scale fill manual breaks equals fill color, right? And then values equals light blue. Add that in. And then I also don't need the title. So I could do that in labs. I'll do it here in the fill. I'll do name equals null. And so now I've got fill color. I need to change the label to be recession. And we'll do label equals recession. And that's good. We need to go ahead and decrease the font as well as the key height. We'll do legend.text equals element text size equals 7. And then we'll do legend.key.height equals unit, and I'll say 7 pt. So that might be a little bit too short. In theirs, it was a little bit taller than their text. And so let's go ahead and make that say 9. We'll do legend.position equals inside, and that will allow us to use the coordinates. So we'll do legend.position inside, and let's do like 0.8, 0.8. Okay, that's got it there, but we want it to be, maybe let's try 1. So let's do y to be 1. All right, so that's getting there. We do have a background to our legend, but we still want to move it up a bit. So let's get that up to say 1.1, and that's way too far. So let's go halfway with 0.05. All right, we can come down to maybe 0.03. And I think that's good if we get rid of that background. So we'll then do legend.background equals element blank. I noticed that their word recession is basically right justified on the plot, whereas, so ours can move over to the right a smidge. So let's try 0.9. Okay, let's try 0.92. It's taken a while, but I think we've done a pretty good job of re-implementing their figure. Now, my sizes and my colors and my margins aren't identical to theirs, but I think it's pretty good, right? I'm pretty happy with the way it looks. Again, my final number here on the right is different from theirs because I've got data going out to 23. They only have it going to 22. Good for me, eh? So again, I'm sorry this video was so long and involved, but there's definitely a lot going on here. I'm pretty happy with the way it came together. Let me know what you think of this and how you might improve the appearance of the plot further. I have to say that I'm not totally sure that we need both panels to have the number in millions and the poverty rate. To me, feels a bit redundant, right? Basically, what I think is happening is that the population is growing, right? And we don't have that data here either, right? And so I feel like the poverty rate is perhaps more important than the numbers, right? Of course, like this means that the number of people in poverty is going up, even if the percent has been pretty constant, right? And so it is interesting that the poverty level has been pretty flat for the past, I don't know, 50 or 60 years. Although, of course, the number of people under poverty is more or less what it was back in 1959, right? And there's been a lot of initiatives to reduce poverty. But again, the population clearly has also grown. So I have said way too much in this episode already. If you want to get this plot, by all means, go down below in the description. There will be a link to a blog post that you can go to get the code to regenerate this. I'm impressed that this ended up being 128 lines of code. Better save that before I accidentally delete it. All right, so I've said enough for today already. Please make sure that you've subscribed to the channel, and I'll see you next time for another episode of Code Club.